All right, so this question is very similar to what we did for question number 3. All right, when we look at this question, we can pretty much quickly see that we're talking about change. Anytime we're talking about change, we're not worried about Formula 1, we're not worried about Formula 2. It's either going to be Formula 3, 4, or 5. Let's figure out who our players are so that we can figure out which of Formula 3, 4, or 5 it's going to be. Let's read the question. A container holds 300 liters of air at a temperature of 4 degrees Celsius. If the temperature of the balloon is increased to 12 degrees Celsius, what should the new volume be? All right, before I proceed with this question, I want to point out a couple of things. Remember when we had to use the ideal gas formula, formula number 1, we had to make sure that temperature was in degrees K, or in other words, Kelvin, instead of degrees C, Celsius. We don't have to do that when we use formula 3, 4, and 5, as long as our old temperature and our new temperature are in the same unit. And what do we mean? If we look here, we see that both our old temperature and our new temperature are both Celsius. So anytime we're using these formulas, if the units are the same, we don't have to do any conversion. We can use the numbers just like they are. All right? So let's figure out who are our players. Our players are always going to either be pressure, volume, temperature, or moles. All right? I went ahead and I outlined or underlined them, and then I outlined them to the side for you. So we see that there's a volume of 300 liters at the beginning, and we see that that volume changed, and we want to predict what that is. So we know that there is a volume 1 and there is a volume 2. Okay, we're going to predict that based off of the proportionality to temperature. And we see that there is a temperature 1, and we see that there is a temperature 2. So because our players are volume and temperature, we automatically know that it couldn't be Formula 3, okay? All right? It has to either be Formula 4 or 5, similar to the logic in the last question. Even though, yes, both my players are in Formula 5, just like they're both in Formula 4, there's no reason to use a bigger formula, Formula 5, and possibly make a mistake with the extra letters if we already have one that has only the players that we need involved. All right, so what are we going to do? Follow the steps as always. First step, ID the formula. How do we ID the formula? We just went over that. We have volume twice, we have temperature twice. We want to know how they change and how they relate. The only formulas that talk about that are 4 and 5. The best one that only has the players we need is Formula 4. Okay, so we're going to use Formula 4. Step 1, we just identified it. Step 2, rewrite it. So Formula 4, V over T in the beginning, so side 1, as compared to V over T in the ending, so side 2, okay? All right, this is how I'm going to copy the form for this question. It's going to be different than the ones that are written straight across, all right? Let me move this chair. All right, so anytime it looks like a proportion, I'm going to set up my math like a proportion. All right, so you're going to see me write the equal sign in the middle and my 2 lines on the side, okay? And I like to write boxes to just remind myself to do something with those spots, okay? This should be looking like a proportion. And the reason I like proportions is because anytime it's shaped like a proportion, we can do that grade school, first grade butterfly method that people tend to know how to use. All right, so this tells me my spots. Top left is for volume 1. Bottom left is for temperature 1. Top right is for volume 2. Bottom right is for temperature 2. I just go back up to the question. What was the first volume? The first volume was 300. So I'm going to plug in 300 liters. All right, let me look for temperature 1, bottom left box. Temperature 1 was 4 degrees Celsius. So I'm going to write 4 degrees Celsius. All right, now let's plug in volume 2, top right box. Volume 2 is what we're looking for. So then I'm going to mark that with a question mark. Like with the other questions, I'll remind you that we use a question mark the way that you use the letter X if you were like in algebra class. It's the thing that we are solving for. All right, and then our last variable to plug in would be the second temperature that I accidentally marked as temperature 1 again, temperature 2, okay? That is 12 degrees Celsius. I'll write that here, 12 degrees Celsius. All right, so whenever you have something set up like a proportion, there are only 2 steps, okay? That the steps are crisscross multiply and divide, Okay, so you're going to multiply, then you're going to divide. Now notice I didn't say across multiply, cross multiply. I didn't just say multiply, because when I say crisscross, that tells you what numbers to multiply. So if you go diagonally and you see two numbers, okay, whichever way you see two numbers. So I see diagonally in this direction 312. I see two numbers. If I were to do it this way this time, then I don't see two numbers. There's a number and a question mark. So that tells me that I go by these two numbers, 312, to multiply them. Crisscross multiply. So then I'm going to say 300 times 12, okay? 300 times 12. That's the first step, all right? Divided by, let me rewrite that so I can write it straight across. I'll write it right here. 300 times 12. All right, the second step is division. You divide by whatever number you have not used. What number did you not use? The 4, okay? Divided by 4, okay? And whatever you get when you put that in the calculator, bam, that is your answer. So what did we do? We found our players. We found out that we had 2 of each player. Only 3 formulas, that's either 3, 4, or 5, gave us that type of situation where we have 2 of each players. 2 of them had the variables we needed in them, volume and temperature, okay? All right, and there's no reason to use a bigger formula if one of them is already exactly what we need. So we identified our formula, we rewrote the formula, we wrote our form, which is the form of a proportion. We crisscross multiplied and divide after we plugged those values in to solve. The end.